Imagine a future where we no longer solely rely on our planet's finite resources. A future where precious metals, rare minerals, and even water can be found in abundance among the stars. This is space mining. Space mining, also known as asteroid mining, is a revolutionary concept that has captured the imagination of scientists, engineers, and visionaries alike. It involves extracting and utilizing the vast riches hidden within asteroids, comets, and celestial bodies scattered throughout our solar system. These celestial bodies can be composed of iron, nickel, platinum group metals, and even water ice, which is a precious commodity in space exploration. The implications of space mining extend far beyond mere economic gain. It could provide the necessary resources for building and maintaining space colonies, fueling interplanetary missions, and supporting humanity's long-term survival in the cosmos. Join us as we interview Cam Dickinson, space exploration scientist and technical lead at MDA.
Hello, Cam. Welcome to the Base Level Podcast. This is episode number 4. Thank you for having us. Just before we get started, I just want to say a big thank you to Ben Greaves. He passed me your information. He said that you would be a great person to talk to in regards to space mining. Ben Greaves was on episode number 2 of the podcast. So Ben, if you're listening to this when you come back to the US, hopefully we can buy you a beer or, some way to repay you. But anyways, it's a pleasure having you on. This has been an episode that I've kind of been wanting to do for the past 2 years. I just haven't been able to find somebody. Just really quick side note. I have a friend who is actually working in the aerospace engineering sector. And he was the one back in 2019 that first told me about space mining. And before that, I had never heard about space mining. And eventually that led to me going down a huge rabbit hole of researching what space mining is and it even being a reality to go and mine asteroids. So thank you for coming on.
Yeah, my pleasure. This is great.
So Cam, what is it that you do? I know that you currently work as a space exploration scientist for MDA, but what is it you do and how long have you been working in the aerospace industry and space sector?
So I started life actually as a chemist. I'm not an engineer. And I got hired onto this company, MDA, about 13 years ago as a planetary scientist. So I was working on a mission called the Phoenix Mars mission. It was a mission where we set up a little meteorological station on the surface of Mars, and we actually found things like clouds going overhead. We saw snow falling to the surface of another planet for the first time.
Oh, wow.
And so, yeah, after that finished and wrapped up, I kind of had to, I was in academia and I kind of had to kind of find more permanent work. So I started working here at this company, MDA. Since joining the company, I'm still doing a lot of pursuits in the planetary science domain, but my day-to-day role is more of a systems engineer. So I kind of help to basically herd the cats with all the different engineering disciplines and make sure that everyone's rowing in the same direction and sort of help them to get to a solution. I guess for the uninitiated, MDA, the company, it's a Canadian company. We're best known for the robotic arm that was on the shuttle and then the robotic arm that's on the space station. And now there's a new project called Lunar Gateway where the robotic arm is going to be on this next-gen space station that orbits around the moon. And we're also known for things like we produce a lot of satellites that do radar. We're able to do things like watch ships come in and out of going across the ocean or through territories where you just want to monitor them and stuff like that. So we do a whole wide variety of sort of space products.
Interesting. And so does that kind of span into the defense sector as well? Satellites that monitor ship movements and all that, I can see being very palpable to government agencies of sorts.
Yeah, that's right. So we basically kind of we package up data products for them, kind of similar to what you're talking about, where it would be monitoring or something like that, and we sell it to different government organizations, whatever their needs are.
Nice. Have you seen, and one thing we talked to Ben about was just kind of the commercialization of space. Have you all seen a boom in business because of that, of different space agencies trying to work with you, or not agencies, companies trying to work with you all to get some of your technology or some of your experience and insights?
Yeah, so there's a big push right now for commercialization. For a long time, space was the domain of governments, and you see a lot of initiatives through NASA for example, like their commercial launch vehicle that SpaceX has taken advantage of, and they've got ton of money from NASA to develop their rockets and stuff like that. And so there's other programs out there that are looking at space stations, like commercial space stations, for tourism and for other things. And for example, for this Lunar Gateway program, the robotic arm that's going on there also has a commercial element to it, and we're pushing hard to develop robotic arms for non-government entities, other businesses that want to use our robotic arms for a variety of things. So we're definitely pushing hard into that arena to be the provider of the best robotic arms in space, and we've been doing it for it's like 40 years since Shuttle, going back to Shuttle. We're the nicest arms dealers in town. So.
Yeah, definitely not selling military arms, I guess. Yeah. So speaking of space tourism, just to get a little off track a little bit, Virgin Galactic just had their first commercial space flight to its first ticket holders. What is your opinion on space tourism and people paying to go be suborbital of Earth? Yeah,
I mean it's kind of following the same arc that we saw kind of in the aircraft industry. It was sort of the rich and famous that had the money to purchase airline flights when they first came out, and once they kind of paved the road a little bit, the prices came down such that more people could access aircraft flights. And now you see, I don't know what percentage of the population has taken an aircraft ride, probably 75% or more, right? So so once the technology is developed, it just gets cheaper and cheaper. So I think we're going to see, a bunch of these different initiatives. Some of them will work, some of them won't. Porting, tourists up into space. Like Virgin is, it just barely kind of kisses space and comes back. Some of them where they have like an orbiting space station, companies like Axiom that they're talking about, other ones that are out there, where they're looking to have like a tourism trade. You can go spend some time up there and really watch the Earth spin around.
I think I've seen something where there's a company that wants to have a restaurant up in space where you can go and eat up there.
Yeah. That's great, right? So all these different initiatives, it's like anything. There'll be some successes and some less successes, and they'll kind of sort out what makes it profitable, and then from that, it'll kind of be survival of the fittest of the ones that. But there's enough players in the market now to really, we'll see a lot of movement in that direction, and probably more and more people gaining access to space, and then again, once you have people coming back and all these testimonials of how fantastic it was and what a mind-opening experience it was to see Earth underneath them, you're going to see a big surge. So I think Virgin Galactic has something like reservations for the next 5 years or something. It's
oh my gosh, fantastic. Who has all that money?
Yeah, they're $250,000 a pop, right? So
they've already booked 800 tickets already, if I'm not mistaken.
Yeah, something like that. So.
Yeah, I'm curious if this is going to be like the new, very remote destination spots. Like there's that hotel that's in the middle of the Nevada desert that's like $8,000 a night, and people just go out there because it's so quiet and peaceful and just a very different experience. If space hospitality and hotels will be the same thing. Where like, I had a spiritual adventure up in space, right? As I ate my steak in this multi-billion-dollar space station.
Yeah, I think it's going to be sort of like a badge of honor, right? To start out with, like, well, what do you mean you haven't gone to the hotel in space? Of course,
there are the Ritz-Carlton in space.
Hanging out. Yeah. So.
Well, yeah, I'm actually really curious to see how that plays out. I'm curious about the sustainability of that, right? These space stations are expensive. We see how expensive the ISS has been. I think it's the most expensive thing ever created by man, right? I think it's trillions of dollars that were poured into that. So I wonder if companies will be able to keep up with that maintenance. Yeah.
So, to their credit, like SpaceX has really kind of turned the industry on its head, and what they've done is the original way that these systems were designed is basically bulletproof, that under all circumstances this thing will last. And what that translates into is a huge cost, and you just test it 1,000 different ways in 1,000 different scenarios to make sure it's going to work. What SpaceX has done and what other commercial entities are doing is they're switching away from kind of bulletproof to more like redundancy, and sort of they're attacking the problem in a different way. So there's a great example where you can buy a computer that is radiation hard and but it might be, I don't know, $1 million, let's say. And maybe SpaceX goes out and they buy 3 computers and they're each $2,000, and they've done the math that says, yeah, there's radiation and one of them's going to go down at some point, per day. I don't know, pick a number. And of the 3 of them, you just have a voting system, and one of them goes down, and the other 2 give the same answer, and you're like, that's the answer I'm going to go with. And so they've gone from $1 million to $6,000, and they get the same. They're willing to also, it weighs a bit more, a little bit more hardware, but that's the kind of thing that they've done to kind of overcome some of these obstacles. All of their reusable rockets, like that's huge, right? The
right.
One-time use for a rocket body, that's a lot of effort to be used for 3 minutes, right? Like it's, and then it's done. So now you can, some of these rocket bodies, like their first stage rockets, I think have made over a dozen flights, or even more, maybe like 20. I've kind of lost track after a while of how many successes they've had. So
yeah, that's interesting. I'm actually really interested. I've made this phrase up and it's probably very inaccurate, but like rugged tech, right? Technology that isn't bulletproof, like you said, but easily replaceable and fixable in case something happens. Like I think the perfect example to me is like the Ford GT, right? It was a revolutionary car. It competed with Ferrari, but when you look at it, all the parts are easily replaceable because they're basic Ford components, right? So I wonder if we're going to move into that model in general, moving to the future, because I think people are tired of buying the $5,000 computer that then you have to spend $1,000 to fix whenever a little thing goes wrong.
Yeah. There's a big push right now for like in Europe to like, for example, your television used to have, 30 years ago you had it repaired, and then for the last 20 years you just toss it. It breaks. The components are like that. There's a huge push for what you're talking about, which is repairability. In the space domain, it's true. They have tried to make some things repairable, but in general, it's like all, kind of stuck in there, and you don't take it out. And so, and it comes down to access for a lot of things. Can you actually access it and pull like a computer out and put another one in, for example, or slap on a new solar panel if you need to? And so that type of architecture is very much being looked at. There's a big push on right now to look at the infrastructure that's going to be used for the moon base. And they have entire working groups looking at that problem, modularity, kind of replacement, this sort of thing. My robot breaks. It's actually just the one part of it. I'll take that piece off and put another one on and let's keep going. So let's not send a whole new robot up there, right? Because that's expensive and these parts.
I would imagine, it would take extensive period of time to get a brand new robot on the on a moon base, and you can just send out a rocket with a bunch of different parts that can probably last you a few years, depending how long they're there.
Yeah, and so and that sort of philosophy is way more economical, right? So now, again, so take the like a huge robotic arm. You don't have to replace the whole thing. You just replace the pieces. And we've done that so far, actually, for the one on the space station and on the shuttle arm, just as an example. But everything comes back to Earth and it gets fixed and goes back up. Well, we can kind of make that transition a bit easier and have it so that it could be repaired maybe on station rather than having to bring it back to Earth.
That makes sense. And yeah, I think time is the factor, right? Well, not only is it expensive, but if there's a Mars colony, which we're hoping to achieve the next decade or two, right? It's going to take 7 months for that material to get there. And then and maybe if it ever comes back, right? 7 months coming back. So you want to make sure you have that leeway, that extra supply to survive.
Yeah. And this push for Mars is you've hit on a great example of, the ultimate use case where, we have to be more independent. And so we have to be smarter about the way that we use these things and less about just, it's easy when you put things up into low Earth orbit. If it doesn't work out, you can probably go get it, or it'll just eventually fall out of the sky and you can put another one up there. But Mars is a whole other kettle of fish. So
no, absolutely. I mean,
literally a whole different planet.
Definitely the first people that are there, they say that they're not the ones that are coming back. So I'd imagine every single item that you take there counts and has to be fixable and replaceable. I want to get into space mining, and There's an article that I want to bring up that I read back in 2019. It was from MIT, and the headline was "How the Asteroid Mining Bubble Burst." And it was basically an article that talked about, the early, I guess, startups that were in this sector. I guess they had been talking about this since 2012, and they are, in the article, they're basically comparing space mining to the gold rush and Manifest Destiny. Do you foresee, I mean, obviously, working in the space, you're optimistic, but as far as it actually becoming a reality, how much time do you think it will take for us to actually mine and refine resources out in outer space?
Yeah, so one of the first companies that started up was one called Planetary Resources. And the CEO of that is a guy by the name of Chris Lewicki, who actually, interestingly enough, I worked with on that first Mars mission. He was one of the engineers from JPL at the time. And yes, there was this kind of boom and then bust around the 2019 timeframe. And this is actually kind of, I'm trying to remember the name of the curve, but there's a very famous work that's been done on kind of these new emergent technologies where you have this first wave, and then they kind of, they don't quite get all the way there on the first push. And then there's a second wave that they've kind of learned from the first wave, and then they kind of get up over the hill. And what Planetary Resources was looking at, was a model to go and sort of mine asteroids, and what they were able to accomplish, they, technically, they were working really hard to get there. But what they really got the needle pushed on was policy. So around, I think it's around 2017. No, sorry, I think it's 2015. The Obama administration signed in, basically allowing companies in the U.S. to begin commercial activities in space, and this is huge. This provides a framework on which companies can start with and can build out. So without that, so for example, right now in Canada, we don't have that kind of the same policy. So if you're a company and you want to do things like get insurance, or just know that when you go and you get a resource, that you will have ownership of that resource, and it won't be that someone else can just say, well, no, that's wrong, or you've done something, could be fined or whatever. You now have kind of coverage that this is doable. There is analogies. I think that the analogy to kind of the Wild West, I don't know so much about the gold rush, but the Wild West for sure. It's a good analogy in that there's a bunch of movement right now to start space mining, and from both a technology point of view and also a political point of view. There's a UN body that last summer was looking at creating international law. So they've gone off. It'll take them a few years to put this into place on international policy for space mining. So this is kind of getting everybody on the same page. The US, with this latest push, they have this thing called the Artemis Accords, and in that there's policy language that talks about mining on the moon. It's not as it's a little bit more subtle than just go and take stuff off the moon, but it does allow for companies to go and extract resources. And so there's a couple of years back, NASA actually put out for tender if a company could go and get them some different rocks, and they buy it for $1, but it's a very symbolic gesture that they're able to acquire and then sell to a government agency for that, and it sets the precedent and kind of puts the ball in motion. So there's a huge activities. If you look through just the kind of acceleration of different countries adopting this, around 2017, Luxembourg comes on board. They're a very small nation. They're known for things like finance, and they see kind of the light at the end of the tunnel, and they adopt policy that allows them to mine space. And they've had a whole influx of countries that have gone into Luxembourg, and they've been able to start mining companies and stuff like that. The technology is catching up, and I'll come back to that in a sec. But following that, there's countries like United Arab Emirates, Japan, and now they've all those are the 4 countries right now that actually have policy relating to space mining. The other big mover that we've seen is China. And China, what's interesting there is they put out policy a few years ago, a statement that said by 2049, which is their 100-year anniversary since kind of the country was established, that one of the 5 pillars of their economy will be based off of resources from asteroid mining. This is huge, right? Like this is one of the largest, and could be the largest, become the largest economy in the world, saying we're going to go get resources off of these asteroids. And so this is like really pushing now on all these other countries to play
catch up.
Either catch up or maintain the lead position in this. The technology is really getting there very rapidly now. So around the time of Apollo, if you look at the technology that the astronauts used to get to the moon, if you really were to compare it, like your iPhone is way more powerful than the computer that was on that.
Yeah, I think it's like 1,000 times more powerful. They basically had calculators and
Yeah, they had it was like absolutely amazing what they pushed to the absolute limit every piece of technology they were able to create, and they pulled it off. And now our technology is way better, and it's even more reliable, and so that's one aspect, like things like computing power. Materials, like we've got a lot of materials that are way lighter, carbon composites and titanium and stuff like that they sort of were aware of, and they used in a limited capacity, but not very much. And now we have like the advent of artificial intelligence, which it's a big buzzword right now. But for space exploration, especially if you're going to go to places like Mars, the communication is abysmal. It takes like round trip up to 20 minutes to talk to an asset on Mars. 20 minutes to get an answer on what's going on. So so you need to have something that's there that is going to make some decisions for you about what it's going to do. Now, you're not going to do this for everything, but for some menial tasks, you just want something that's going to like kind of keep the boat headed in the right direction, right? And not having to sit there and manually course correct or something.
Wait.
Like that.
Yeah.
Yeah.
Wait for 20, maybe 20 minutes. It depends on if, the satellites and everything, the relays are in line, and, there's those windows of communication.
Yeah. So all these different things are all pointing in the right direction. So now we've got sort of the policy, we've got a lot of the technology, we've got companies now that are starting up, and basically a lot of them are looking at the moon because of this big push right now for return to the moon. There's a lot of money being poured into the moon. And so they're looking really, the early ones after this, like things like planetary resources, are looking at things more like prospecting. So again, Gold Rush, good analogy maybe. We're not going to go and maybe land stuff tomorrow, but hey, we're going to take we're going to try and figure out what resources are there from all the data that we've collected, and we'll sell it to different companies that then maybe want to go and take a stab at and landing an asset.
Mine at it. Mm-hmm.
Yeah. There's like personally, I'm actually way more bullish on asteroids. And for a couple of reasons. One, the moon is, I think, probably one of the most inhospitable places to do engineering in our solar system. It is absolutely like just so hard. So where you find like the biggest resource that people are going after to start with is probably water. And where's the water? It's in permanently regions on the moon where it's in permanent shadow. It never sees the sun, and it's about minus 220 degrees Celsius. So I'll let you guys convert that later into Fahrenheit.
I'll have to
in the comments, but it's
Fahrenheit.
Friggin' cold,
Later.
right? Yeah.
9 fits X plus 32, right? I think that's
there. You go. Yeah, minus 400 or something like that. I don't know. Yeah. It's cold, right? And so you're going to go run machines in there. And at that temperature, you talk to anybody that's in mining right now, and they're happy if their machines run like 100 hours. and that's in like a mine. And so if you want to have a machine in that cold environment running continuously, for more than a few days, like all the best to you. So my beer bet is on asteroids, and they are very plentiful. There's millions of them. They have a variety of different minerals. And if you look at, so I worked on another mission called OSIRIS-REx, which was a mission to an asteroid called Bennu. And one of the big findings was that Bennu has tons of water. I think I worked it out. It's like $5 trillion based off of how much it costs to launch like a kilogram.
Current market value. Yeah.
Of material into space. Trillions of dollars just sitting there orbiting around. If you go to Bennu and you pick up some of the material, it's actually pretty easy to get material off the surface. When they did the like OSIRIS-REx, the mission was to collect a sample and return it to Earth, and they blew a crater in the surface that was 7 meters in diameter and half a meter deep, just with nitrogen gas, just gas, like this. And they locked it up, like I can't remember how many. It's like tons of material, like around 2 tons or something like that. Lofted it up into the air, and then it slowly fell back to the asteroid. It's easy to pick it up off the surface. Like it's not like hard rock mining on Earth with explosive things. You just need just that use of gas. There's other ways to do it, but
it's not like Armageddon the movie, right? With Bruce
Willis. Bruce Willis. Yeah.
Yeah.
So and you look at the technologies that you need. They've that mission and other missions. There's 2 missions from the Japanese show you can go to asteroids and kind of and contact them. That part's been done. It's been demonstrated. So now we're at the point of let's collect some material, and as it works out for Bennu, if you heat the material up to about, sorry guys, I'm going to use Celsius again, about 700 degrees Celsius. It's at 1200 or something Fahrenheit. The material just decomposes and you get water spontaneously. And so you can collect that out and bring it back to what we call cislunar space, which is between the Earth and the Moon, and sell it. And right now water's the hot commodity because it's used for a lot of different things. It's used, the first one that you guys would be thinking about is for humans, but the bigger one is actually as a propellant for all the rocket motors. They can fuel up with water, and they can just, start kind of traversing around the solar system. And if you want to go to Mars, let's do it on water rather than all this fuel that we have to load up a big rocket.
Burn and waste. Yeah.
Yeah. But, and it's expensive, right? To pop that up into orbit from the Earth's surface. It's expensive. You burn a lot of fuel just to take fuel with you, right?
Yeah.
So if you can get it up there from a different means and it's cheaper, everyone's going to use that. So that's the so this second wave that I was telling you about before, this is happening now, and all these different companies are starting up, and they're looking at different ways to either look at water or look at mineral extraction, and a lot of them are, like I said, are looking at the lunar surface and how we can do that, because they want to do like a manned presence a crewed presence on the surface of the Moon, and they want to have resources like water present there. So there's a lot of different avenues for these technologies to kind of be built up in the next little while.
I think you're stimulating my questions here, and you actually answered a lot of the questions I had. But a couple things. I have a conspiracy theory that Elon Musk and Jeff Bezos are actually in the space game for asteroid mining and space mining. I don't think they care about the tourism piece. I don't think they care about transportation. I think they're in it for mining. I don't know. That's a conspiracy theory there. There's also some socio-political theories that I've heard, and I'm like, oh, that's interesting. But the other, I'm super excited about all this. I majored in physics in college, got my degree in that, and a lot of my interest was just on the space industry, and that was kind of where I was hoping to take my career. I think like every kid, I thought I was going to be an astronaut. Didn't work out. Now I'm working in government tech, and we talked about that earlier. But it's always interesting to see like the way industry will kind of expand and explode with space being involved, right? We talked about, Bennu having $5 trillion worth of water. Now, is it really $5 trillion worth of water? Who knows? Who knows what the economics will look like if that's introduced to the market? But it's insane to see that these resources that we think are limited and, are scarce are plentiful just at really arm's reach in comparison to the scale of our solar system. And, there's a show that's on HBO Max, which I highly recommend. It's called For All Mankind.
That's a great show.
Yeah, I love that show, and they kind of speak on like the ice caps and those craters, and then the North Pole of the moon, and what it could do for space travel, and not only just for the economy, but what it allows us to reach. So it's exciting to hear that's a real possibility, and that it's something we're expecting to maybe accomplish in our lifetime.
Yeah, no, I think in the next decade, you're going to see demo type missions starting to happen, and people they'll probably be, to start off with, government funded. They'll start doing demo missions to show that, hey, this technology actually works. And once you have that in hand and saying, we did this, then companies go, great, I want to use that, and I'll start, mining. And whole industries will then start up around these things. There's a lot of the water, for example. There's a lot of infrastructure that would have to get put into place. You'd need almost like a gas station kind of orbiting around the Earth to deposit it into. It's not insurmountable, though. Nothing of that whole supply chain is insurmountable. I think infrastructure into space. Once you have that in place, you have just one gas station, and people are pulling up with their rocket ships, and and then you just build two, and then you build three, and there you go, right? So you're on your way.
Space, supply chain, and logistics. How freaking cool!
Yeah.
Well, I would imagine so, because a lot of the articles that I've read, they mention that the resources that are mined in space are going to stay in space, and that they're going to be refining the resources out there because it's not economically viable to bring it back to Earth, right?
Yeah, there's a few exceptions. Like there's a big fight over what's called rare earth elements. These are elements that are used a lot in for
batteries,
electronic components and batteries, and that where they are located in Earth, there's a number of different places. A lot of them are in China, and if you're going to have there you go. Yeah, so if you're going to have a trade war with a country that has sole access to some of these things, then it could get kind of dirty, where they're saying, well, you can't have access to our rare elements.
It's like, okay, well, we'll just go get an asteroid. That's kind of where my sociopolitical theories came from. We see China buying up land in Africa. They're kind of having this trade war with the rare earth minerals. And it's like, well, maybe we don't focus on the Earth battle. Maybe we focus on the space battle, where there's maybe even more of the material that we need than we could ever expect, right? I think Mars is supposedly a prime candidate for that possibility, right? Because it is similar to Earth's composition, and there might be plentiful, areas where those materials are available.
That's right. Yeah. So the cool thing too about asteroids is a lot of them come by the Earth. Bennu actually comes by the Earth every, I think it's 7 years, and it's predicted that it could actually hit the Earth in about 140 years or something like that. We'll all be long gone. But and that was one of the reasons actually for the OSIRIS-REx mission, was to study that. But what that means is you can literally have these orbits that come close to Earth, well, you can drop off bags of water or minerals or whatever, if you pick the right asteroid that kind of comes by. And even if not, then you can kind of, shuttle your way around the solar system and bring it back. Mars gets a little bit more tricky just because of the distances, and you're definitely not going to, it doesn't come close to Earth's orbit. But and then the other thing is you have to escape Mars's gravity to get back up. So you've got to really want those resources if you're going to take that path. But there's probably easier places to get it. So
that'd be cool, using maybe asteroid Bennu as like a slingshot of its own carrier, right? Like, oh, well, we know Bennu's going to hit this part of the orbit. We could drop some stuff off here, pick it up later, right? That'd be really cool. Yeah. No, exactly. It's a little bit more complicated than just drop it off, but it's you got to kind of it's all about timing, right? So it's doable. It's totally doable. So and you just maybe the time frames are a little bit longer, but you can, once you start these processes, you can have like a regular cadence of water being dropped off, and literally tons of it.
So now you've got your supply chain working for you.
And so I guess we've talked about OSIRIS-REx and the Bennu mission in a couple of different pieces here. The one thing I'm interested is this, I think it's like laser altimeter, right? And its use of LiDAR to kind of scan Bennu. Is that correct? Or kind of what was the use case there?
Yeah, so I worked on that mission, and I was, so basically the Canadian government funded this laser altimeter, or a LiDAR. How this works is you use a pulse laser, you send out a pulse of light, and it travels from our instrument to the surface of Bennu. It hits the surface and reflects back. And then you have a telescope that detects the light that comes back. And you know what the speed of light is very accurately. And so you just mark the time between when the pulse left and when it comes back, and that tells you the distance, how far away it was. And so you do that 3 billion times, and what you get is the surface of Bennu every 4 centimeters, and that's what we got. And so we know the entire Bennu right now is the most highly surveyed body in our solar system. So we don't know. We know every 4 centimeters what the height of the asteroid is, and even better for some of the images that were taken. And so what we're able to do with that is, for example, we can look at the volume of Bennu, which sounds boring, but if you want to work out sort of the density of this whole asteroid, you need to know the volume, and then from its orbit you can figure out the mass, and now you can get what the volume or what the density is, and that tells you things about what material is inside and how much material is inside. And the really cool thing about Bennu is it's about 4.2 billion years old, I think, and it's kind of like a time capsule of our early solar system. And so
the same age as the Earth, correct? I think the Earth is about
Earth's
5
about
billion years old.
5 billion, yeah. So, and our solar system's around, a little bit older than that. And so this was the material that was flying around when the Earth was like in its early stages. And so so we take some of this material, bring it back to Earth, and then we can study it slowly and carefully and kind of go, oh, this is what the material that was floating around at that time looked like. Which is super, awesome in terms of, just understanding. Like humans are such explorers; they want to just figure out why things are the way they are, and sort of what did it look like that time ago. And we haven't figured out the time machine yet, so this is the next best thing. And we can really, get a handle on, what these early days look like.
If you know anyone that's working on a time machine, we'd love to talk to them, by the way.
Yeah, we can go back and redo your first podcast with the
exactly. Yeah.
So now, what work are you currently doing with AI? That being a buzzword, and how has that impacted your work currently with space technology and space mining?
Well, I'll talk when I start a little bit more broadly about what the benefits are AI for, or what we see them as kind of a company. I can also make myself personally, but AI helps to enable things that are really challenging in terms of, again, rather than having a human maybe monitoring something all the time, if you can create sort of an AI agent, what you tend to see is kind of, in a lot of cases, that it's actually better outcomes. I know it's sad, but the computers have gotten so good with some of these things that they can actually outstrip humans, and this is kind of the promise of AI. So for the robot that we're building for this lunar gateway, we're going to have the ultimate goal is to have it almost kind of doing its own stuff, like having it fully autonomous. So the one that's on the space station right now, I'll start with the one that was on the shuttle. That they had the astronauts actually controlling it by hand. The one that's on the space station is pretty close, and then we started controlling it from the ground, and that was a big step. Well, Gateway is the next step beyond that, where we'll probably start by having it controlled from the ground, but we're going to transition over to, either parts of it and eventually, hopefully, all of it, where it's completely making its own decisions on stuff. So rather than feeding it a bunch of go left, go straight, go right, it's just going to be move this box from A to B. You'll figure it out. And so you think about the amount of work and sort of input that goes into, start with the astronaut. You got to send a human up there to actually make the go left, go straight, go right. And then the next part, okay, well, we didn't have to send an astronaut up. We can do it from the ground, but we have all this infrastructure and we had to keep everybody, engaged on that, watching everything while we go left, straight, and right. And now we're just going to have the robot make the decision to go left, straight, and right to fulfill that. And it allows us to do more operations, right? We can do a whole lot more stuff. And the nice thing, the cool thing about this is we're still going to need all these people operating. We're going to get a lot more done because we're more efficient. So, and this is the ultimate goal. And again, when we do things like Mars, and we're looking at Gateway as sort of a first trial run of a space station that would eventually potentially orbit around Mars. It's going to have to, again, 20 minutes is a long time to wait to see if it went left. And then you tell it to go straight and wait another 20 minutes. And then you wait another 20 minutes to go right. Like that's an hour, right?
It's kind of like those janky, like claw machines at the arcades, right?
At the arcade,
and like later it like,
damn it, I went too far. Oh my God.
Exactly.
Yeah.
I could have won that stuffed animal. I knew.
Yeah, exactly. Yeah. So autonomy is huge, right? So autonomy really helps to make things more efficient, and so we can utilize these things better. And once we've demoed these, then we're going to find new applications for them because we are doing things more efficiently. So in terms of space mining, so now I've now demonstrated that I've been able to make a robotic arm move kind of by itself. Well, if I'm out of Bennu, at its furthest orbit, it's actually pretty close to the Mars orbit. And so it's the same kind of scenario. And if I'm going to be mining out there, I can't be telling it like, left, straight, and right. I have to just say like, go collect a boulder or, that level of, and I tell it once a day, here's the boulder, go do it kind of thing. And rather than, there's no hand controls on this guy. So this is the enabling technology that's going to get us into the space mining domain, where and now we can efficiently mine things like that in a small enough amount of time to make it profitable.
One of my favorite videos is it's a 60-minute news segment that they did on robots and AI, and they were covering these two robots that their only objective was to just score a goal. And over time, the robot and the AI just taught itself the best way to score a goal. And I can only just imagine on a larger scale what could be done when mining asteroids.
I think we even touched on like how hostile some of these environments are. You're talking about the dark side of the moon, or in those those craters. But asteroids will probably be in areas where humans have never been before, so we have no clue what the radiation might be like in that area, or what the space climate might be. So having an AI system that can basically do all the work for you without risking the exposure of a human might be beneficial.
Yeah, the risk exposure is really, that's what you've touched on, a good one. Sending astronauts to Mars, that's one of the biggest sort of hurdles is to get through. So we know pretty well what happens to humans in the low Earth space environment where the space station operates, and we're protected by sort of magnetic belts that because Earth has a magnetic field, we're protected like very, very well by these magnetic belts. But but once we get out towards the moon, that protection goes away, and you have to be very careful. Like one of the risks to the Apollo astronauts is like a solar flare, and this is like a massive eruption on the surface of the sun. And if it points in the wrong direction at the wrong time, unfortunately, it's not a good day to be an astronaut. And so if you're going to go to Mars, and now you're spending more time in space, and so there's sort of like a background radiation plus if anything else happens, then you're going to eventually have a bad day. Just to go back to sort of the resources and stuff like that, water again, which is great. Humans need it to survive, and we can use it for propellant. But the other thing is, if you make a spacecraft with a big kind of cylinder of water around the outside, then it will help protect you from some of the radiation that could come. Just in general, radiation from all angles. and it helps the astronauts. They'll be more protected behind several tons of water. But you're not going to want to push several tons of water up from the surface of the Earth up into space, right? So this is another good use case for mining
Yeah, this is
aspects of benefit.
random thought. Yeah, the big jugs of water. There's actually what they use to detect nuclear radiation in some countries and to detect nuclear launches, which is But that's a random point. Sorry about that. That just popped in my
head. Yeah.
Now, when it comes to mining these resources, we're seeing currently on Earth, human rights violations when it comes to mining, and who owns the rights to certain mines in certain areas. What are some of the legal and ethical considerations surrounding space mining? How is that going to be determined? I know you touched on policy earlier, but who is going to be the governing, entity to control who owns rights to asteroids, and how is that going to be monitored?
So right now, what happens is if you put something up into space, you're responsible for it. So if you are the United States and you push a satellite up into space and it falls and hits somebody, you're on the hook for what comes of that. So it's the launching countries sort of they have to basically own that. It looks like what will probably happen is that space mining will kind of follow that same paradigm where the country that launches it up there will be responsible. What happens is one of the big hurdles right now in mining, terrestrial mining on Earth, is actually a lot of environmental protections, because we now the more we study, the more we find that trailings ponds are very bad. And it's what trailings are is after you extract the mineral you want from the rock that you've excavated, it's all the stuff that's left over, and oftentimes there's just really bad elements, minerals that are in there that nobody wants, and so you have to do something with it. It's a lot of paperwork and a lot of policies put in place to ensure that that basically people are protected. And you can see around the world what happens when there's no protections. There's lots of mines, unfortunately, in places like Russia, where they have no protections and the water system is just permanently damaged and beyond kind of all comprehension. So that's bad, right? Nobody wants to be poisoned, and so it kind of makes sense that we have these protections. It just means, well, we have to be more careful with the mining. Well, if you're up in space, you're not impacting other humans, right? There's nothing. So if you want to go and extract resources for use in space, then that's a whole area where you're not going to be impacting. The impact has been removed from that element. Doesn't mean that we're going to stop terrestrial mining by any stretch, but it just means that if we want to push infrastructure into space, we can do it in space. We don't have to pay for that. And for some of these things, if we want to bring it back, like some of these rare earth metals, the abundance is so low that it might actually make financial sense to bring it back from an asteroid and bring it back to Earth, and in enough abundance to one of the ones I've heard about, which is kind of cool, is we just take this big asteroid and we're going to crash it into the Australian desert, and then just go to the cratered site and just pull it out and just mine it there, right? Okay, we want to do that, but
no offense to Australians, I'm with that. There's too many venomous and dangerous things out there, man. It's just let's get rid of that landscape.
That's right. So, but anyways, I mean, they're probably not going to do that. But anyways, it gives you an idea of sort of some of the thinking that has gone into this. So, so people are thinking about these types of problems they're starting to think about them now for space mining, and what hurdles can we overcome? What's the benefits of this that we can do? It's kind of the ultimate green technology, right? There's you have to put a rocket up. The rocket has to launch into a spacecraft. Once you get it up there, and if you can continue to use it, then it's not really impacting Earth after that. So you can start to build out infrastructure kind of in this cislunar space. So it's exciting, right? It's an exciting time to be in the space industry in terms of all the growth that we're seeing and all the different opportunities that are kind of being talked about. And, moon bases and this is all the stuff that was dreamed of in the 60s, and now we've had to wait 60 years for this to actually
Progress.
happen. Yeah. So
Yeah, I feel like there's a more push for space topics being pushed out in social media. I feel like a lot of people are having that interest in learning more of outer space and new technologies. Because before, I think it was just kind of still untapped and a niche area of people wanting to learn about these topics. And if you weren't taught it in school, it's probably you don't know about it. And I think that's how I felt about space mining.
Yeah, I think in general, space is still a pretty niche industry. I think the James Webb Telescope and, of course, SpaceX and Blue Origin, I think those kind of pop culture shifts helped. But even now,
Definitely.
I don't think the coverage is there, right? Where there's a lot of advances that are happening in space that would really affect our day-to-day life and improve it. But we're just not, people aren't paying attention to that just yet.
Yeah, and this is that pop culture was what people experienced in the 60s and 70s.
60s, 70s, yeah.
It was super exciting, right? Even the 80s with Shuttle, super exciting, right? To go and see one of these things. And then it kind of just sort of flatlined a little bit. And just sort of, it's taken another initiative like Artemis to go back to the moon and push for that to really recapture everyone's imagination. And now people are harnessing that to, things like SpaceX and orbiting hotels and this sort of thing. People can start to dream about that and go, yeah, that let's make it a reality. So,
and I would imagine too, there's a lot of who's going to be the first one to do it. So there's a huge push for that as well. There's huge motivation behind that.
Yeah, and for some of them, it will be first in will kind of be the winner, and for some of them, it might take a couple tries to do that, like we saw with the sort of space mining with the first startups and stuff like that. So it's going to be interesting and probably a challenging time for a lot of these companies. So, yeah.
Great. Well, Kev, I think we're coming up on time here shortly, but I have one last question. It's something I asked all of our guests. We talked about LiDAR a little bit earlier, and I know there's a lot of applications for LiDAR, whether it's autonomous vehicles. There's some applications in medicine in terms of just topological exploration, or is it topographical? Whichever that one is, topographical, right? I think that's it. Exploration. But is there any other technology or development that you are excited about just watching outside of AI? I know we talked about that a little bit too. But there's like something that's happening that you're like, wow, this is going to be beneficial for humanity and just exciting to see continue to progress.
Oh, wow. Good question. I would have to say that there are a number of different experiments going on where they're able to do things on station, where they're able to make materials that we can't actually make in a gravity environment. And so it's kind of a niche area, but they're if you think about trying to make something that can't be made on Earth, and then what the benefits are, that's definitely a good an interesting case to for having the infrastructure kind of low Earth orbit, kind of zero gravity. There's there are advances in medicine that also come out of the astronaut program, because they have to really understand the effects of like extreme temperature, extreme gravity loads,
radiation exposure.
And kind of really the limits of the human body. So we have seen a lot of advances because they understand a bit more about the effects of radiation on DNA, and like what does radiation exposure do. Things like aging, that's kind of that's another one, and even there's there's effects on aging is actually a cool one. A student intern of mine went off and did a project on a parabolic flight where they were looking at this thing called telomeres, which is the very ends of your strands of DNA. And as you age, it's kind of like the, on your shoelace, like you have that little bit that's got the hard plastic nub at the end.
The aglet.
Yeah.
The aglet.
The plastic thing at the end that nobody ever knows what the name of.
There was a whole cartoon episode on this. It's called The Aglet, fellas.
Okay. There we go. So the aglet of your DNA is called the telomere, and as you age, it just gets shorter and shorter. And then once it runs out, then you basically start digging into the DNA itself. And so that it's almost like a fuse, right? And what my student was looking at was this is a project she did on her own, not with me, but was like what the effect is on zero G. So that's really cool, right? Because they've done aging experiments with like twins. One of the twins went as it was an astronaut and one stayed on Earth. And so what's the difference in their sort of aging profile because of being in zero G for so long? And how much of your telomere has been either saved or used up by going into space. So it could be like we learn about just things like human aging and what happens when we're in different environments. That's really everybody wants to live forever. So this is this side of data you just can't get in it everywhere. So
yeah, it is interesting to see the in-space manufacturing. There's actually a company we're hoping to speak to next, is Varda Space Industries, where they're focusing on manufacturing and medicine creation in space stations. And I always love to hear about the aging profile thing, because of course that's like Einstein's thought process or thought experiment, the special relativity case, where if someone's out in space away from gravity, who ages quicker. I'd be interested to see if there's any heavy research on that.
Yep, that's something that that's something that you've had to explain to me multiple times, because I can't grasp that being a thing. I guess it's called a time dilation. It doesn't make any sense to me. I recently rewatched Interstellar, and I was just telling them how I was like, that's complete bullshit that they leave to another planet and then it's 20 years on Earth, and then
it's a real thing, man. The universe owes you no explanation or any reason to make sense. Okay.
Well, Cam, do you have any social media that people can reach out to or that you would like to share?
The best one for me is probably to find me on LinkedIn, and maybe we can do this as part of you. I think you guys are on LinkedIn, so we can maybe do that as part of the distribution of this podcast. They can find me that way.
Absolutely. We thank you for coming on, and hopefully we can do this again later down the road once we do a little bit more research on space mining and talk to a little bit more people involved in space technologies.
That'd be great. I'd love to join you guys soon.
And once Christian understands time dilation.
There'll be a quiz at the beginning.
Exactly. Yeah. Special relativity quiz here. But yeah, I think this was a fantastic episode. Thank you again, Cam. I think this was wonderful.
No, my pleasure. Yeah.